Mastering API security. API errors can be a hacker's best friend. What strategies can our organization employ to handle errors and exceptions in API responses in a way that minimizes the amount of sensitive information that may be inadvertently leaked to potential attackers, thereby mitigating the risk of API exploitation? To handle errors and exceptions in API responses without inadvertently leaking sensitive information to potential attackers, an organization should employ a multi-layered approach that includes the following strategies. Error handling. 1. Generic error messages. Return generic error messages that do not provide detailed information about the error. Instead of returning specific error codes or messages, use high-level error codes that do not reveal sensitive information. For example, instead of returning a username or password is incorrect error, return a general authentication error message. 2. Sanitized error messages. Implement a process to sanitize error messages to remove sensitive information. This can be done by using a whitelist approach, where only specific error messages are allowed to be returned to the client. Any error message not on the whitelist should be caught and replaced with a generic error message. 3. Error codes. Use standardized error codes that do not reveal sensitive information. For example, use HTTP status codes 400, 401, 403, etc., that provide a general indication of the error without revealing specifics. Exception handling. 1. Catch-all exception handlers. Implement catch-all exception handlers that catch all exceptions and return a generic error message. This prevents any sensitive information from being leaked through unhandled exceptions. 2. Logging and monitoring. Implement logging and monitoring mechanisms to detect and respond to exceptions. This allows for quick identification and resolution of issues, reducing the risk of exploitation. 3. Stack traces. Disable stack traces in production environments to prevent sensitive information about the API's internal architecture from being leaked. API response. 1. Minimal data. Return minimal data in error responses to prevent sensitive information from being leaked. Only return the necessary information required to troubleshoot the issue. 2. Data encryption. Encrypt sensitive data in error responses to prevent interception and exploitation. 3. Data masking. Mask sensitive data, such as credit card numbers or passwords, to prevent them from being leaked in error responses. Infrastructure. 1. API gateway. Use an API gateway to act as an entry point for all API requests. This allows for centralized error handling and exception handling, reducing the risk of sensitive information being leaked. 2. Load balancers. Use load balancers to distribute traffic across multiple servers, reducing the risk of a single point of failure and minimizing the attack surface. 3. Network segmentation. Implement network segmentation to isolate sensitive areas of the infrastructure, reducing the risk of lateral movement in the event of a breach. Testing and validation. 1. Error simulation. Perform error simulation testing to validate that error handling and exception handling mechanisms are functioning correctly. 2. Penetration testing. Perform regular penetration testing to identify vulnerabilities and validate that sensitive information is not being leaked. 3. Code reviews. Perform regular code reviews to ensure that error handling and exception handling mechanisms are being implemented correctly and do not reveal sensitive information. By employing these strategies, an organization can minimize the amount of sensitive information that may be inadvertently leaked to potential attackers, thereby mitigating the risk of API exploitation.